back when we were talking about eclipses, we discussed that there can be some interesting alignment between the sun, the earth, and the moon to give eclipses once in a while. So for example, if here's the sun, and here's the earth, and here's the moon, sometimes as I've shown here, the earth can move between the sun and the moon. So what is happening here is as light from the sun is trying to sort of stream across the solar system here, it would certainly like to go out and illuminate the moon, but it can't because the earth is blocking it. There's another configuration where the sun might be here, and the moon might be here, and the earth might be here. And of course the sunlight does its usual thing, streams across the solar system, and it runs into the moon. It would like to go on and illuminate the earth, but it can't because the moon is in the way. And so these are the conditions of eclipses right here. And the first one, where the earth moves in the way, this is called a lunar eclipse. And where the moon moves in the way, this is called a solar eclipse. And you can always remember these because the term in the front always refers to the thing that's being blocked. So when it's a lunar eclipse, it's the moon that's being blocked by the earth. When it's a solar eclipse, it's the earth being blocked by the moon. And what I'd like to talk about in this video is this configuration right here, because we still have a little bit of work to do on this so-called question number 14, which asks about why does the moon turn red during these lunar eclipses. So in other words, I'm saying exactly what you think I'm sort of saying here, is that normally when we look up the moon, like a nice full moon like that, it's very bright and white, sometimes even hard to look at, and you can see the sort of the Maria in there all over like that. But my position here is that during these lunar eclipses, the moon takes on this reddish hue like that. You can still see the Maria and all that sort of thing, but the whitish part that you're normally seeing definitely takes on a reddish look. And I want to show you a web page here that illustrates sort of what it looks like. So if I go over here, the web page that I'm showing you is this one called Time and Date here, and they have a bunch of nice stuff on that site you can sort of look at. And I wanted just to show you then that this is sort of what the moon can look like during one of these so-called lunar eclipses. So you see some whitish in there, but by and large it's very, very red, and it's called a blood moon. And this one happened in September 2015. This is not a very unusual thing to happen. It happens every so often. Even in my own lifetime, I've seen probably 6 or 7 of these. It's just a normal evening, but you just go outside and the moon turns red. So I'd like to discuss that and make sure we get that answer to question 14 all done. And I think you can know the answer to this because all of the facts we need are already out there. So in order to answer this, I would just sort of throw you the expert opinion on what air is now, what air plus light does. So as we know this from the red sunsets and the blue sky, that I'm just going to sort of cast air to be, I'm going to call it a blue light filter. Blue light filter, that's what I'm just going to call air. And we know this because if we have a bunch of air here, which is our atmosphere, again, nitrogen and oxygen, and then what happens if white light tries to travel through this air? So this is white light. And of course we know what white light is. It has red in it, and it has orange in it, and it has blue in it, and it has yellow in it. White light has all the colors of the spectrum, but the point is that if this white light tries to penetrate through a bunch of air here, which is sort of what I'm setting up, this is our air here, then what comes out on the other side, as you know now, is as you know, everything except blue. You'll get red, you'll get orange, you'll get yellow, you'll get some green, but by and large, the blue is absent. And that's what I mean by a blue light filter. White light goes in that has that blue in it, goes through the air. When it comes out, the blue is gone. So that's what we mean by that, okay? So what we'll do now is we'll go back to our lunar eclipse situation and try to figure out why this is happening. So the first of all, of course, the sun is a nice white light source. All of the colors of the spectrum come out of it. But what happens during the lunar eclipse is here's the Earth right here. And here's the moon. So I'll sort of draw the moon as a gray outline at the moment here. That'll be the moon, okay? And so what happens, of course, is it's a very oversimplified model to think then that light's going to leave the sun like this. Here comes the light here, and simply hit the Earth like this and not make it over to the moon, okay? Because what happens is, of course, there's some light that just barely misses the Earth, maybe goes like this, just above the Earth, and just above the Earth like that. But of course, the complete view of the Earth is that we have an atmosphere around the Earth too, right? So it's not just about the Earth itself, because the Earth has this nice atmosphere around it like this. And what is that atmosphere? Well, that atmosphere is full of nitrogen and oxygen. So there's the Earth's atmosphere I'm trying to draw on. And so what happens here, of course, is the white light hits all of this air. And what we're calling the air here is a blue light filter, for the reasons that you're familiar with now, from the blue sky and the red sunsets. So if it's a blue light filter, then what happens is, as the white light keeps going through the atmosphere like this, just on the edges of the Earth where it skips, I mean, these light rays are sort of unaffected, those light rays are unaffected, but these here that just sort of go through the Earth's atmosphere, you know what happens. The blue light leaves. All this blue light sort of leaving the beam here and here and just going into outer space or down to Earth or something. But the bottom line is, what happens is the rays that emerge from the Earth's atmosphere are all that red. So the red's going to start coming out here and here, and the orange is going to start coming out here and down here too. There's some orange and the yellows and that sort of thing. So in other words, everything except the blues, and maybe we'll put a little green in there too, a little green there, everything except the blues, because the blues all got extinguished because air is this blue light filter. But one other thing is, it would be sort of also maybe confusing to go, well, the light ray's traveling nice and straight, isn't it just going to go on by and pass the moon like that? Well, no, because remember what happens up here, right at this position right here, there's a boundary between the atmosphere and outer space. And so if you remember your law of refraction again here, where the atmosphere is something like an N1, or that's going to be way too thick, an N1 like this, the atmosphere is an N1, maybe 1.007 or something like that, and outer space here is N is equal to an N2 of 1.000. So it's going from a high index of refraction to a low index of refraction. And what light does when it does that is it bends away from the normal. So if the normal is going to be somewhere in the atmosphere, we'll get a little bending of the light. And so this light that's coming out of the atmosphere at the atmosphere space boundary is going to bend down towards the moon. It's going to be refracted. So that reddish light is going to leave and sort of hit like this. And let's draw a little bit of thicker red. It's going to hit like that and a bunch in there. And let's get a little bit of orange in there too. Get some orange going in there like this. And maybe some yellows too, and that sort of thing. And all right, put a little greens in there if you want, but predominantly not greens. And so what happens is then the moon just takes on this reddish color from all the reds and yellows and oranges. So you just get this moon here, which starts to be all sort of filled in reddish like that. And that's the nature of the red moon. So it involves two things. It involves that refraction, which we learned about in one of the laws of light, and it also involves this idea here that air is a blue light filter. So all of this white sunlight has to just skim right through the Earth's atmosphere on its way over to the moon, gets bent by a little bit of refraction, we end up with a red moon. So one more look at that website, because it has some nice discussion and details on it. If we go back, that's sort of what the moon looks like that I mentioned. But if we scroll up, you can see just sort of a professional graphic here. They say, well, here's the sun, here's the Earth blocking it, and there's the moon there, which would otherwise be unilluminated. But here's, I think it's a nice graph here. They show that blue light leaving the sun's light there, the way I've drawn. There's the blue light leaving. See, Earth's atmosphere scatters blue light. We used the word scatter a couple of videos ago. And so what you're left with is predominantly red light going in, hitting the moon like that. And they have a nice description of up here too. It's not a scientific term, a blood moon, but it's widely used to refer a total lunar eclipse, because the moon often takes a reddish color. Okay, so why does it turn red? And just sort of you read the description here, I hope it makes sense to you here. Some of the light still reaches the lunar surface indirectly, and again, even though the Earth is hitting it, but it has to go via the Earth's atmosphere, bathing the moon in reddish, yellow, or orange glow. As the sun's rays pass through the atmosphere, some colors in the light spectrum, those towards the violets, or the blues, are filtered by a phenomenon called a Rayleigh scattering. We'll just keep it as scattering in our class. This is the same mechanism that causes colorful sunrises and sunsets, Red wavelengths are least affected by this effect, so light reaching the moon's surface has a reddish hue, causing the fully eclipsed moon to take on a red color. Isn't that nice? Okay, well, there you go. There's sort of the complete answer to question 14. It's blocked by the Earth. There's scattering out of blue in the atmosphere and a little bit of refraction in there.